Okay, so this is part 2 of section 5.5. This shouldn't take too long to get through. I just want to give you a couple of examples of where synthetic division might be useful for you. So the first thing is that if you see this right here, it says 1, 0 of f of x equals x to the third plus x squared minus 16x minus 16 is 4. So they're telling you one of the zeros is 4. What is another 0 of f of x? Well, one of the things that you could do is you could use synthetic division to do this. So like if I know that one of our zeros is 4, then that means that one of our factors is x minus 4. So if that's the case, then all I would need to do is if I take x to the third plus x squared minus 16x minus 16 and divide it by x minus 4, I would figure out what my remaining quadratic function is, and then we could factor that. Now, we're not going to do that for this problem right here. It's just to give you an idea. So the other thing you could do on a multiple choice is you don't need to divide. Don't waste your time. Just plug these values in and figure out which one gives you 0. And if you do that, you'll find that -1 gives you 0, because if I do -1 to the third plus -1 squared minus 16 times -1 minus 16, you will get 0. So if you ever get a multiple choice, don't worry about the dividing it and doing all this long process. That's a waste of time. If you know what a 0 is, then just plug your values in and see what gives you 0. Now, if the problem's a little bit different, say in the second one where it says factor 2x to the third minus 11x squared plus 3x plus 36 completely. So if we don't know how to factor that, which it very well may be that you don't know how to, but if they give you what one of the factors are, we can do this, because now we know that the 3 is on the outside for our synthetic division. We put all of these on the inside, and we go to it. What's going to happen is we're going to end up with a quadratic function to end, and we can factor it. Now, the one thing you have to notice is this right here. That is very important. If we did not end up with a remainder of 0, then we could never, there's no way we could factor this anymore. If we know that this can be factored more than just pulling out an x minus 3, or if x minus 3 is a true factor of this, then we have to get 0 as our remainder here. Okay, we're not just simply dividing it. We know that x minus 3 is going to be one of the factors of this. Therefore, the remainder has to be 0. So what we're left with then is we have this part of the function, which is 2x squared minus 5x minus 12. And then we also know that we have x minus 3. So in other words, if we were to multiply these two together, we would end up with this function right here. That's exactly what we're doing, is we're breaking this down. Now all we have to do here is we can factor this. If you can't, you can't, but in this case we can. So if I keep factoring, I will get two factors that look like this. 2x plus 3 and x minus 4. And then we still have our x minus 3 here. So now what we've done is we have factored this completely. That is the point of this, is using synthetic division helps us to factor trinomials if we know what one of our factors are, because then we can get that factor and we can get the other two factors once we get to our quadratic. So hopefully that helps. Again, see what I did again, ask questions tomorrow. But as I said, this would be less than 5 minutes. I promised that. I got there. So bring your questions tomorrow. I know this was a tough section, and we will spend a couple of days on this.